Welcome back. We're going to continue our discussion on aldehydes and ketones. As the first step in the process, we're going to learn how to synthesize aldehydes. And I like to keep the entire synthesis routes to either one video, maybe two. And I must also tell you, from now throughout the course, it's not possible to walk through the mechanism for every one of these reactions. Then we would never really be able to complete the entire course material in a prompt time. And also, learning mechanism for every single reaction does not necessarily mean that it doesn't mean much if it's never going to be tested out of this class. So I have to keep that in mind, because professional exams like MCAT or dental exams does not necessarily test a mechanism for every one of these reactions. Just the common ones that are very famous, I will explain the mechanism, but for some of the others, I'll just tell you a shortcut way of remembering the synthesis. All right. With that said, let's get going. And the first mechanism we're going to learn is oxidation of a primary alcohol. Okay. Now, you could use any of these three reagents. Now, the trick with organic chemistry is, at least this particular courses, there will be a lot of reagents, so you must find a way to remember. Now, as I've told you in Chem 330, how do I know sometimes when I know a reagent is oxidizing? Well, typically the reagent that's at the top of the arrow, if it's extremely oxygen rich, then it means it's oxidizing agent. That means it enables oxidation, right? That means a primary alcohol will go to an aldehyde, and a secondary alcohol will go to a ketone. So again, you must find some ways. Now, this PCC is nothing but a polychlorinated chromate. Okay, you do not have to, I'm not going to quiz you that, but if you're wondering what the PCC stands for, it stands for polychlorinated chromate. Again, that's got the CR and O in it. Chromate is CRO in it, so that again is an oxidizing agent. Okay, so let's draw a practice primary alcohol. Now, I hope you have not forgotten, primary means carbon with 2 hydrogens, right? Secondary means carbon with 1 hydrogen. Tertiary means carbon with 0 hydrogen, right? Now keep in mind all of this have, right? Take 2 other bonds. But the idea here is hydrogen. So this is a primary alcohol because the carbon that's containing the OH group is containing 2 hydrogens, right? Now we can use any of these 3 reagents. For now, I'm just going to write oxidation at the top. You can use any of the 3 reagents I've indicated here. And all you have to really do is, I think we learned this reaction towards the end of Chem 330. So just replace that single bond OH with the double bond L. And that's it. That's aldehyde. Okay. Now I'm going to put all of this up. Okay. So I know what spaces I have to work this entire screen with me. Now an acid chloride. Now again, I may not repeat this information over and over again because then it gets just redundant and it wastes time in the video runtime. So R can be a CH3, or CH3CH2, or CH3CH2CH2. You can just keep going, right? So RCOCl, now that's called an acid chloride because technically how we got this is because we took an acid and treated it with HCl and we got acid chloride. So whenever an acid chloride reacts with this crazy reagent, which is called lithium tri-tertiary butoxyaluminum hydride, do not worry, I'm not going to quiz you the name of this reagent. But that should tell you, well, this long name means I'm doing reduction. Okay. All we're really going to do is, let's say this is generic version. Say I give you this as your aldehyde or acid chloride, and we're going to put this reagent in here, and it reduces. All it really does is replaces the Cl with the hydrogen. And that's it. It's just that simple. Replace the Cl with a hydrogen. Bingo, there we go. You have an aldehyde. Similarly, ester, we did an entire lab on fragrance of esters. Okay, again, R and R prime could both be CH3, CH2. You can have combinations of it. Okay, I'm just going to do just one really quick, where I'm going to keep both ends the same. You can also change them up. Keep one end CH3, the other end CH2, CH3, and so on. Okay, plus this crazy long reagent, diisobutyl aluminum hydride. Again, you must find some way of remembering. Typically, hydrogen rich indicates reduction. You can see that. So when we throw this reagent in, again, we're going to replace this whole portion with the hydrogen. Okay, so that means our product would be H. How simple is that? Same deal with a nitrile. What's a nitrile? Well, again, R can be any of those. That's a generic. The C triple bond N, which is a cyanide, but in a compound, it's known as a nitrile. And when this reacts with the same exact compound as it's shown above, when I throw this reagent in, all you have to do is replace this C triple bond N with a C with an aldehyde group. Okay? Say you had started with a CH3, CH2, C triple bond N plus this reagent. That's the reducing agent. All you have to do is replace this portion with an aldehyde group. So CH3, CH2C. That's why I showed you the generic structure earlier. So this is the aldehyde portion. And that's how you do this reduction of an acid chloride, an ester, and a nitrile to an aldehyde. Okay, I think we may have time for one more. Then reduction synthesis of an aldehyde through an anti-Markovnikov route. And this time we're using an alkyne, which is a triple bond containing compound, plus either this, which contains the boron, or this crazy compound, which is 9-BBN. Okay, if you see this reagent, again, even if that's not the thing, you're all so familiar with this hydrogen peroxide. So the BBN is known as this diisomal borane. Okay, so this is a generic structure of an alkyne. Okay, make sure that one side contains a hydrogen. So when I give you a compound, typically I will only give it to you in this fashion. Okay, this is an alkyne, or I've chosen it to be CH3CH2. Now I could make it as long as I want or how short as I want, but this end would remain the same. Now when it reacts with either of these reagents, all you are going to do is, I'm going to just use this maybe for time being. I can also use this, but this is a much more cost-effective agent. So when it reacts, all we're going to do is write the R portion exactly the same and add 2 hydrogens to the carbon containing no hydrogen, and replace the triple bond with a single bond, and then add a double bond O to the carbon that contained the hydrogen. So 2 hydrogens goes to the carbon with no hydrogen, and double bond O goes to the carbon with 1 hydrogen. And replace the triple bond with a single bond. That's exactly what I have done. Okay, now I can give you another compound, which is this, and you can solve the product using either one of those reagents above. But the key thing here to remember is anti-Markovnikov is indicated by the hydrogen peroxide and a strong base. Okay, so you can solve this one, and that's it. This is the product. You see, we ended up with an aldehyde. All right, so stay tuned. I will see you back with with maybe one more video on either aldehyde or I'll see you with synthesis of ketones. All right, so stay tuned.